Hi, I'm Alistair Curry from Infrastructure News, and today we're talking to Louis Cheyne, Managing Director of Gabion Baskets, and we're talking about environmental engineering and constructing with gabions. This is CPD on demand. Hi, Louis. So welcome.
Thank you very much for having a chat to me.
Yes, it's such an exciting subject, and it's an ancient one, isn't it?
Yes, absolutely. It dates back many, many hundreds of years.
So perhaps you could expand. We have an interesting program today. I mean, the history and practice. Can you expand on how solutions with gabions have evolved over the years?
Well, you know, I've looked back. Obviously, it's of interest to me. I've been in the industry now for 25 years. The gabions have dated back hundreds, if not thousands of years, with the ancient Egyptians having used them for soil retention and remediation along the Nile River in North Africa, thousands of years ago. And then they've been used extensively in the American wars, civil wars, and also in Europe initially in the 1800s. Initially they were more circular in shape, cylindrical gabions, and now they've changed to be more square box shaped. So that's very interesting, and they came into South Africa in 57, and they've obviously evolved as time goes on and become more and more useful in many industries.
So why the 50s? That sounds quite late for gabions in South Africa.
Well, I haven't researched it further, but that's when a particular company I used to work for came into South Africa. But I don't think they were manufacturing in South Africa at that stage. They were still importing from other countries into South Africa.
Right. Okay. And I mean, a gabion is clearly not a wire box that you throw rocks into. What are some of the common misunderstandings with gabions?
Yes, absolutely. A lot of people think that it's just a box to throw a rock inside and it contains, and as long as the box is full of rock, it's fine. But there's obviously some rudimentary principles that need to be followed so that, number one, it's structurally sound, and number two, it looks aesthetically pleasing. Because in the past, maybe 20 years ago, we used to supply predominantly into the civil engineering industry, but now it's changed focus, where it's becoming a lot more popular in the householder type industry, in the architectural market. So it needs to look good, number one, and generally if it looks good, it's been built correctly, because there's certain things that have to be looked at during construction phase.
Right, could you expand on those, please?
Yes, absolutely. And this is why we've done animations on our website, and we distribute animations. In the past 25 years ago, we only had video at that stage, but then we decided which is the best way to educate our customers with the usage of products on sites. Often they're too far away, we might have shipped the product, so we felt the best way is to electronically let them know how to do it. So we have cartoon type illustrations, and then we also have animations which we can email them, and we also have video footage on YouTube that they can certainly have a look at. But there's quite a few specific things, and we actually supply a toolkit for the installations to make it easier for them to achieve a nice structurally sound gabion. But obviously on the other side we also supply skilled gabion installers on the one hand if required by a client, or we supply skilled trainers. So we spend a week on site and teach the people nicely how to install the gabions. Because generally in an installation on most of the projects we're encountering these days, the government or the client wants to use local people to do the work, and often those local people are unskilled with gabion installation. So obviously once we've finished on site, we then allow these people to have a qualification that they can use going forward on other projects as well.
Right. So Louis, I mean, within civil engineering, where does the discipline of gabions sit? How comprehensively is it covered at universities today?
Well, I know when I went and studied, I never even knew about gabions. I studied at Technikon in Pretoria. But once we got into the gabion industry, we did at that stage 25 years, and we still do now, as we go into universities and technikons, to educate them on the uses of these products, because they're widely used in the civil engineering industry to stop soil erosion and also for retention purposes. So, obviously from the contractor's point of view, his staff need to know how to build the gabions and what's important, but also from the engineer's point of view, the client's point of view, they need to make sure that the engineer's representative on site knows how to monitor the installations. And he can't monitor the installation correctly if he doesn't know some of the rudimentary principles behind the installation.
Right. And what about some of the engineering codes? How do those apply in this field?
Well, we've got two specifications that we adhere to specifically. We've got a factory manufacturing specification in terms of the quality of the Gabion box itself, which covers the galvanization, the wire tensile strength, the sizing of the boxes. That's the SANS, the South African National Specifications 1580, which covers all of those things I've already mentioned. And then on site, the installation part of the Gabion is covered by SANS 1200 DK. So that's on the one hand for the installation on site, on the other hand the manufacturing of the baskets, to make sure that at the end of the day the client gets a quality product.
Right. And your involvement with the consulting engineering profession, is that quite extensive?
Oh yes, absolutely. I come from a consulting engineering background myself. But we do many presentations for engineers within their offices to teach them about the specifications of gabions and how they can be used more environmentally friendly, which we'll chat about a bit later, environmental ecology principles. And we often work with engineers where they have a particular problem. We come up with some possible solutions that they can consider. And also on the other side, the price estimates. And normally on these projects, they have an allowance in their bill for training on site. So we would also assist them with that as well.
Excellent. And you've touched on it, but labour-intensive construction, it's been around, it's been discussed, but it doesn't seem to be happening as fast or as wide as it should. The role of gabions in this situation, how would you place it?
Well, that's what's very exciting for us, because obviously in our factory is very labour intensive, but obviously on sites as well, on many sites it easily lends itself to labour intensive mechanisms. In Europe they're very machine intensive, but I think in Africa we want to create more employment for our people in the country. So gabions easily lends itself for that purpose, where most of the installation, the erection of the baskets, the packing as well, is all done by human beings, and we assist in that, and we train these people to be able to do it nicely.
Right.
So on all of the projects it's very labour intensive.
But we're talking about, can we expand on the products? Because we talk about gabions, but there are Reno mattresses, there are a whole range of other things, sausage gabions. Where does it begin and end, Stuart?
Well, in the past I used to be a monoproduct supplier, which we only supplied the galvanized baskets, the square baskets, which we call gabions. At that stage we also supplied the flat gabions, which we refer to as Reno mattress. We caused ours river mattresses because the word Reno comes from some of the first work that was done in northern Italy in the early 1880s. So you basically get the box gabion and then you get the mattress gabion, which we call a river or Reno mattress. And that in the civil engineering profession is mostly been using woven mesh, hexagonal woven mesh products. But then we realized that in a lot of cases there's a lot of corrosion possibilities. So we always use the heavy duty galvanizing on our mesh, and then we started using the PVC coated mesh, which has a 0.5 millimeter or 500 micron PVC coating to protect it from corrosion in areas where you have high acidity or you're near the coast where you have the salt corrosion problem. So then we started supplying both the galvanized plus PVC coated materials. But then about 10-15 years ago, we internationally, the square welded mesh gabion was very strong, and in South Africa it wasn't that strong, but we felt when I started up this company 11 years ago, there was a real need in the architectural market for a gabion that was a little bit more rigid and better looking. So we started manufacturing the square welded mesh shaped gabions, which we use in the architectural, home, building, industrial market. But there's quite a wide range of gabions now. We produce small 300 by 300, 1 meter or 2 meter long gabions we call gab blocks as an alternative to a concrete block. We supply the bigger type sausage type gabions, which is more of a cylindrical type gabion that you might use in a rivet for founding a gabion structure on. And then we even have the gabion we call a gab tail, which is a gabion facing with a horizontal mesh tie back into the full situation so that it laterally reinforces the slope.
Okay.
So we have obviously the facility for quite a wide range of solutions using gabions. As in the past it just used to be the box or the mattress, but now it's obviously on the environmental and geotechnical field, it's really opened up and become a lot more interesting.
Right. Fascinating. And when we talk retaining structures, how do gabions compare against concrete blocks?
Our main competitors, obviously the reinforced cantilever concrete wall with steel reinforcing in it. We probably about roughly 50% of the cost of a reinforced concrete cantilever wall, depending on the local conditions that I'm talking about, a Johannesburg situation. And then obviously concrete blocks, it depends on the type of structure we're building, because in a lot of situations, most people think that gabions need to be a pyramid-shaped retaining structure where your base width is 55 to 60% of your height. So for instance, if you have a gabion wall 5 meters high, your base width needs to be 2.5 to 3 meters wide in a mass gravity type situation, founded to a 10% of height depth. But in a situation where you just need a retaining wall for surface erosion protection as a revetment, then obviously we can just use a 1 meter or half meter wide wall, step back up the slope to retain the slope. So in those sort of conditions, depending on where the rock's coming from, it can be very price competitive when compared to concrete blocks, especially if the transportation. So there's a number of different factors you have to take into account. Right. It's very difficult to compare one to one. Exactly. If we just compare the cost of a basket, X works, that we need to compare it on-site constructed,
Right. And are there areas of concern in terms of failure when it comes to design? What are the common causes of structural failure for gabions?
The main causes for gabion failure are mainly 3 or 4. You have sliding, overturning, overall slip stability, and then obviously in a river situation you can get undermining of the structure. Okay. So those are the 4 main principles where when we do a design check on a structure before it's built, those are the points to be considered. Sliding forward of the structure, overturning, overall stability, and then undermining in a river situation where you have a very silty foundation. Obviously a clay foundation, it's going to be reasonably good, but in a silty soil foundation, the soil can easily be washed away, so we need to consider a mattress apron type revetment in front of at the top of the structure.
So anchoring and lacing, could we expand on those areas? Because I think that's connected to what you just spoken about.
Yes. When we're building a gabion wall in a riverine environment, we need to make sure that the foundation of the structure is adequately looked at before and prepared before the gabion structure is placed on the top. In a lot of riverine environments, we find we have very uneven situations, and you might have a lot of holes, eroded scour holes, So in a situation like that, we always like leveling it off first with the primary layer of rock to fill those holes and level it off. If we're building a gabion structure on a rock platform, uneven rock platform, then all we need to do is just to level that rock platform off with the concrete founding layer, so that we can place the gabion, and the gabion doesn't go up and down, it can go more or less straight along the foundation of the embankment. Now in a situation where we are placing a gabion structure on a river soil foundation, we prefer to have a mattress lining underneath the gabion structure, at least extending into the river for a length of 2 meters. Unlike concrete apron, the concrete apron is inflexible, the mattress apron is a flexible structure, so that your wall might be here but your mattress will be there, and your mattress can still move once erosion takes place at the end of the mattress. So you find in most riverine gabion structures we design it like that.
Right. And Louis, when it comes to settlement as opposed to concrete, I think there are some advantages.
Yes, absolutely. With the gabion structure, it's slightly more flexible than concrete or even the concrete block systems. The concrete block system relies on a mechanical interlock. And if that interlock is broken because of some subsidence below the structure, the whole structure starts failing. Whereas a gabion structure, as you might understand, it's composed of a whole lot of different units, but these units are tied together with the binding wire, so that the whole structure is one unit, and that's how it performs. So if you get any positions of poor founding soils under specific areas, the gabion structure can actually bridge over those areas and basically support itself, which is quite nice.
Absolutely.
Because often in riverine environments you have differentiating soils. For a certain length of the structure you might have clay soils, then it might change to silt, or you might just have loose stone there, and that's why we need to. So we don't need a concrete foundation under mattresses or gabions. They act as their own foundation, unlike the concrete structure or a concrete block type system.
So Louis, can you expand on the scope for gabions, and perhaps giving us a breakdown of some of the commercial applications?
Yes, absolutely. Obviously, gabion products have been mainly used in the retaining wall industry to stop soil erosion on the one hand, but also to prevent embankments failing. So that's one of the main applications. Then the secondary application is in river courses where we have significant soil erosion and embankment instability. Then we have longitudinal structures that on the one hand retain the soil but also stop soil erosion in rivers to prevent property and industry from being undermined or damaged with the floods. And then we also have structures that are built in the mining industry for water diversion type structures, a primary crusher walls using either mass gravity solutions with gabions or the reinforced soil gabion application with the horizontal steel mesh or high strength geogrid type tiebacks. And then obviously in rivers we have quite a few different types of interventions. On the one hand, we might want to train a river in a certain direction, either by partially going across the river with a river groin using gabions, or going totally across the river with gabion weirs to, on the one hand, reduce water velocity flow coming down the river and encourage deposition of sedimentary material on the upstream end of the gabion weir, and have controlled areas of water dissipation on the gabion spillway. And we've done quite a lot of that extensively in South Africa upstream of dams to prevent all the silt from coming from the water catchment into the dam. So another application is obviously coastal belts where we have coastal protection structures with gabions as well. But obviously a gabion can only withstand a wave of 300 to 400 millimeters height. The bigger waves need to be, the gabions need to be protected with large boulders in front of them to prevent them from being damaged. So those are the four main uses of gabion: retaining walls, river walls, weirs, groins, and reinforced soil applications.
Right. Thanks, Rupert. I've also heard there are some unusual applications coming out these days, like fish farming, is that?
Absolutely. Well, we've worked with a fish supplier here in Johannesburg where he built a few fish hatcheries in Pretoria and locally here in Joburg using gabion structures, because the gabion structure acted as a support for walkways and to contain the water, and also as a mechanism for the biofiltration of the water, in other words, to clean the water. Because when the water flows through the rocks, it purifies the water or cleans the water. So that's an interesting application. On the other hand, we also have used gabions to build some houses and some homes, and that's looking quite interesting on the international scene as well.
And what about some of the other broader municipal applications for roads and park areas and that sort of thing? Is that quite a big take-up area?
Yes, it's becoming more and more so. I mean, on the architectural side, we're starting to build gabion structures, pillars around buildings for municipalities and industries, gabion benches, and then obviously river walks and small erosion control structures, small terrace walls where we have a steep embankment and we need to create terraces where people can walk along. Sometimes even in the Drakensberg we've used gabions for hiking trail stability as well. So it's quite diversified now.
Very interesting. So my next question, Louis, is about quality. Is there an issue with inferior products on the market?
Absolutely. I think that's goes once again back to the idea that a gabion is a simple basket to throw a rock inside. And obviously gabions have been around now for over 100 years, so there's a lot of research that's gone into it. We use the hexagonal woven mesh for gabions, which meets the SABS specification, but we're finding in Africa that some of the people just think they can buy some mesh from the local hardware store and use that and fill that with rock. And often that mesh they get from the hardware store, the wire's too thin, it's not galvanized. And then we even find that there's some people trying to import products from overseas that don't necessarily meet the South African quality, the stringent quality regulations. So we do have some problems with that, but normally we speak to the consulting engineer to educate them on what to look for on construction sites when this becomes a problem.
So Louis, we've been talking about structures, you've been talking about the soil conditions, particularly in river systems, but we can refer to other systems like retaining structures. Who's responsible for actually signing off the project in terms of the survey?
Normally the sign-off of the project is signed off by a qualified peer engineer. So oftentimes we might get called in by a client themselves, or we might be called in by an engineer to come and have a look at a certain problem that they have on site, whether it's a gabion retaining wall or a river erosion control problem in a river. And then we would propose certain remediations to be done, typical design proposal, but we oftentimes need to have an engineer sign off the design drawing. When we work with engineers, they normally do that themselves based on our technical proposal, or we work with geotechnical and also hydraulic engineers around South Africa who give us that technical support, which is very important as well.
I'm sure. And in terms of erosion control, how accurate is the hydrological assessment?
That depends very much on the research that's been done on a particular project. Obviously nowadays a lot of the engineers are bringing the estimates forward because of change in climatic conditions. So the parameters they used to use for river hydraulics in the past don't really work anymore. They've got to make them much more stringent. So they've got to bring the years forward so that they can do a much more accurate technical assessment. I must say that in most cases the proper research and technical design is not done, but on the bigger project it is done by the hydraulic engineers or the geotechnical guys that do that.
Right. And geotechnical implications for retaining wall structures. Is drainage a requirement, or does the permeability of the rock surface?
The drainage requirement is very important. As you can imagine, with a typical concrete cantilever wall, it's very important from a drainage point of view to either drainage designed with subsoil drains and geotextile full fin-time drains behind the structure, but also to allow for water drainage through the structure using weep holes. However, the gabion structure is obviously a free draining structure because you use a geotextile to prevent the soil from going through the gabion structure. The gabion structure has about a 35% void ratio, 65% solid rock. So as you can imagine, the free drainage of water is very easily done. And when you're designing a gabion structure, you need to take into account the different soil parameters in the foundation soils and your backfill soils. Parameters like the cohesion of the soil, your fire ratio of the soil, your density of your soil, and whether the soil is exceedingly clayey or very sandy, because all of this has an effect on the end design or end result of the gabion that's being placed there.
Right. So now that we've covered that topic, how important is the area of geotextile technology for these structures?
The geotextile is very, very important because, as you can imagine, a gabion on its own, because of its high void ratio, will easily allow the passage of water through the structure from below and from behind. So in a very sandy soil, if you get a high water table in the embankment and the water starts flowing through the gabion structure, it's going to take the fine particles of soil with it through the gabion structure, which is going to lead to subsidence. Now we don't want that. We want the water out so we don't get build-up of phreatic pressure behind the wall to push the wall over. So we place a geotextile at the contact zone between the back of the gabion and the embankment soil, but also below the structure as well, in a riverine environment especially, so that we don't get subsidence below or behind the structure. Especially when you're retaining an embankment next to a roadway, you don't want the whole roadway to stop subsiding because you're getting lots of fine embankment soils below the road.
Could you expand on the types of geotextiles?
Yes, absolutely. Internationally, you get two different types. You get the woven geotextile, which is a woven product, and then you get the non-woven product that is predominantly made by two suppliers here in South Africa. That is mainly used in areas where you've got very granular type soils or very sandy type soils. When you've got a situation where you're founding on a clay type soil or backfill, you need to consider the type of geotextile you're using, because the geotextile can clog with the fine clayey soil. So in that sort of instance, you might not even use a geotextile backing with clay soils, or you might use a woven type mesh product that has bigger pore spaces so that the water can pass through, but it doesn't clog itself within the dimensionality of the fabric.
Okay. And where do geosynthetics fit into the equation?
Well, the whole geosynthetics market has now expanded quite dramatically. In the past, it just used to be geotextiles and gabions, but now we're starting to talk of fin drain type mechanisms, high strength geogrid applications for lateral soil reinforcement. So there's geocell type applications for soil erosion protection. So the field has widened quite dramatically late in the latter years because of the advances in polymer research and technology.
Could we expand on design and costing and the construction aspects for these types of structures? What do people need to know? What's important? How expensive do they get compared to other technologies?
Yes, absolutely. Obviously, we assist the client or the engineer with the design of the gabion structure, but also at that stage, he'd like to have a price estimate of how much it's going to cost him, depending on if we're using a galvanized basket or a PVC coated basket, and the destination of the site, because obviously labor costs vary around South Africa depending on where the site is. So we'd have to take the local conditions into account, where the site is being, where the quarry is, because most of the time the rock is sourced from a commercial rock source. We don't like taking rock out of rivers, it damages the environment. So we prefer, so with gabions there's three main cost parameters when you come to looking. It's the gabion itself, the gabion mesh or the basket, whether we're using a Class A galvanized or a PVC coated basket. The price difference there might be 40 to 50% more expensive using the PVC coating, but bearing in mind that then you have a design life of minimum of 60 years, even in an aggressive environment. And then the newer type technologies, we're also using the galfan materials, where we have a look at a price increase of 5 to 10% over Class A galvanizing. Now the galfan materials are being used now with 5% aluminium, 95% zinc coating, because they give an extra corrosion resistance over and above the normal Class A galvanizing coating. So you have the three options then. You have the Class A galvanizing, the galfan coated wire mesh baskets, or the PVC coated baskets. So that's the price difference in those. So that, with the costing of gabions, we're looking at three different costs: the cost of the basket, the cost of the labor, and the cost of the rock. In Johannesburg, we normally split it about 30% for the basket, 30% for the rock, and then the remaining 40% is normally the cost of the labor. Currently in Joburg, the pricing on baskets installed is about 1,500 to 2,000 Rand per cubic meter, depending on the size of the project and the localization of the project. Because obviously if you're bringing in a rock from a long distance, it becomes a lot more expensive, because they normally charge the rock per ton per kilometer. And then obviously on the labour side, the labour in Johannesburg could certainly be a lot more expensive than a remote site in Sabi, for instance.
Right.
So that's why you just need to have a look at the local parameters. And obviously the smaller type projects, a job of 30 or 40 cubic metres, is certainly going to be in the range of 2 to 2,500 Rand per cube, as opposed to a big structure of 3 to 4,000 cubic metres of gabion work, where your price might come down to 1,300 to 1,500 Rand per cubic metre.
Okay. Does the Department of Public Works, does it have sliding scales for these types of projects?
No, not necessarily. I suppose it just depends on the tenders that go out and how competitive the pricing is. Sometimes the government and the municipalities do contact us for price estimates on works, and certainly the consulting engineers do. And then they would base their bid estimate on those prices, and obviously when the tenders come in, depending on how busy everybody is, the prices could fluctuate slightly.
Right. So you're speaking about Johannesburg, obviously being a larger urban area. For rural areas, you touched on it with the cost of transportation, but how are the calculations done there? I mean, do you ever try and use local in-situ materials?
Absolutely. For instance, in a very remote area, you might be near a mine, and obviously the projects on mines are very easy, because then you just need to really pay for the basket and for the labour. You've got the big source of rock there. And on the remote side of things as well, you might look for a commercial rock source, but if you've got a mine nearby, you can source your rock from the mine. And sometimes in areas, depending on the type of structures that's being built, they can source the rock from site, some of the rock from site.
Right.
And then maybe use so they would use the local in-situ rock for the front of the basket, so it blends in with the local environment, and then contact the quarry for the rest of the rock, which might be a blue type angular aggregate, and then fill that at the back.
Are there ways to reduce the rock volumes in situations where you do have limited supply?
Yes, absolutely. Sometimes we're in situations where we bringing in rock from a long distance and becomes very expensive. What we have done in those cases, we can use sandbags, and sandbags are filled with local sand or in-situ material to fill the basket. Or we might use a combination system of rock just on the front face, for a distance back in the basket of maybe 200-300 mils, and then the rest of the basket can be filled with a geotextile sock with in-situ material to reduce the cost of the final structure.
So maybe let's go to the factory now. What's happening here? I mean, where do your materials come from in South Africa? And what is the process from the factory to the site?
Okay, the wire that's used for the manufacture of the Gabion mesh is sourced from the likes of Mattel Steel or Score Metals. They produce billet, and then from billet they produce the wire, what we call wire rod. That's normally about a 5.5 millimeter diameter rod. It comes in big jumbo coils of about a half a ton per coil. And then my partner Barnes Fencing buy in those coils of rod, and then they draw the rod, which is ungalvanized. They draw to the thickness required, and then they Class A galvanize it, and then they produce that into jumbo coils of about 800 kilograms per jumbo. And then those jumbos are fed into the hexagonal double twist machine in their factory, and then they produce the rolls of mesh for us. Those rolls of mesh might vary depending on the type of basket we need to make, from 300 to 500 to 1 meter to 2 meter widths, normally 50 to 100 meters long. So then we buy in those rolls of mesh into our factory here, and then those rolls of mesh are stored in our storage area and they're pushed through our production, and then the manufacture of the basket takes place from that. The necessary cutting of the mesh, and then the edging of the mesh, which we'll show you, and then the final assembly of the basket. And the basket comes to site packed flat like a flat cardboard box, and then it's unfolded on site to erect the baskets. But we manufacture the baskets here at our factory, and then they're packed flat and they're compressed in our compressor so that we can get many numbers into a small volume once they're transported.
Okay. So some of your products are off the shelf because they're standard, and some are clearly customized
Yes, we have about
solutions.
Yes, we have about 15 different sizes of baskets, whether they're Class A galvanized or PVC coated or Galfan. So we keep a range of the most common sizes, your most common size Gabion being a 2x1x1, or the mattress being a 2x1.3. We have quantities of those in stock, but obviously for the bigger orders, or sometimes a person needs a special size, we need to consider whether we can manufacture that size. But in most cases, the lead time on small type orders is a few days to a week or two.
Right. And Louis, when it comes to on-site, I mean, we've spoken about training, but what actually happens for local labourers? I mean, surely it's a fairly involved process to assemble these baskets.
Well, it's not too difficult. We supply the baskets to site, and then they unwrap the baskets, and we hopefully would have a person of ours on site to show them how to unpack and how to fill, and the correct sizing of rock to be used, how to fill these baskets. So I think that's why it's also been used very successfully internationally, is because it's quite easy to do Gabion installation. It's slightly more difficult to get them looking really good, but the process of building a Gabion structure is reasonably easy.
Okay.
You know, we can train up unskilled people within 1 week how to do very good looking Gabion structures.
Excellent. Well, I like that reference to good looking, because that was my next question. Talking about greening and environmental and bioengineering, could you expand on those areas?
Yes, absolutely. That's becoming more and more important nowadays. Obviously, on all these big civil engineering projects, they have environmentalists looking after the environment, and they're very particular on where structures are being placed and how they're being built. In river run scenarios especially, obviously the Gabion being very porous and being very rough and angular type aggregate with the fast flowing waters in a river type situation, you're going to have sedimentary soils being carried in suspension, and when they meet up with the Gabion type structure, because of being so rough and angular, it tends to slow the water velocities down and then deposition that sedimentary material being carried in suspension, and then Once that happens, which happens naturally over a period of time, you start getting the growth of the vegetation on top of the gabion structure. But the environmentalists nowadays prefer us designing the environmental type system into the initial design phase of the structure. So we're finding now that we are using local fauna and flora to cover the structures and to grow through the structures and to blend in with the local environment, so that within a period of 3 to 6 months after the installation's taken place, the structures are totally grown over, especially in a river embankment situation. You don't want to see the mattresses. We would rather topsoil them and encourage growth of local grasses and shrubs, because that happens very naturally, very easily. As you can imagine, the gabion has the mesh on top of the rock, and vegetation likes creeping and growing into the rock. And even the bigger type shrubs grow out of the baskets, and then the mesh naturally moves out of the way to facilitate that process happening naturally. So it's becoming more and more popular now, where we build gabion structures. We advise on ways of growing creepers and shrubs into the gabion structures by allowing for pockets, allowing for river willow to grow through the structures and totally camouflage the structures, make it more pleasing for the local birds and fish to live on gabions.
Just another question. I mean, how resistant are gabions to fire? I mean, in a veld or an environment.
Obviously, a gabion is composed of steel, so there's no real problem. And in most cases, the veld fires take place and they go past quite quickly. The only thing that might be a bit of a concern is if we've got a PVC coated gabion structure. But even the PVC coated has a burning threshold of about 160 degrees. So it can withstand quite a lot before it starts melting.
Right.
It really can.
And just moving into a bit further into bioengineering, maybe from an aesthetics point of view, are there trends there in terms of PVC colouring to blend in?
Yes, absolutely. We have structures in the Western Cape now where they're mostly using the Table Mountain sandstone within the gabion structure, and with the Table Mountain sandstone not being a grey colour, being more of an in situ tan or yellow or brownish colour, we're starting to go for a different coloured PVC coating. Instead of using the normal grey, we're starting to recommend using a tan or brown coloured PVC coating, so that you don't see the mesh with a brown coloured rock. You see the rock, and the mesh colouring is almost hidden. Okay. Camouflaged.
So Louis, we've covered so much ground, and now I have to ask the question, what have been some of the most difficult challenges? And for you, what are some of the classic case studies in the industry when it comes to environmental engineering and gabions?
Well, over the past few years we've encountered so many problems of a river type environment damage with the change in climate. Especially last year there was significant damage here in Johannesburg with the floods that came through. So we were called to many sites where we had to assist landowners and industry with some solutions. So we feel, and always there seems to be with landowners a dispute whether who pays for all this work. Is it themselves or is it the municipality? And who actually does the work? Because that's the difficult thing. Most homeowners have household insurance, but they don't necessarily have insurance for the damage that can happen on their riverine environment with boundary walls, etc. So that is part of a big problem. I think in the whole of South Africa, where you get infrastructure being damaged with floods, and the repair is necessary and the capabilities there, but who solves the problem of the intervention to secure the embankment? Is it the municipality pulling in specialist geotechnical engineers and putting it out to tender, or is it the client paying for some of the works himself? So that's a bit of a dilemma we faced over the past few years, where clients don't necessarily have the funds to to fix the problem appropriately.
So perhaps an example of one of the more dramatic interventions in your experience?
Yes, we've obviously done a lot of work. I'm thinking about Sunning Hill a few years ago, where there was extensive damage for industry and municipal bridges, where we did a lot of gabion installation there, where the contractor was appointed by the consulting engineer, and we supplied the baskets to site. We were involved in some of the design of the structure, but we also assisted on site with the training. There was some work that was done in front of industry, and some work done around the bridge abutments with gabions to stabilise the bridge abutments, because we did quite extensive damage after a flood that had taken place there. But that went quite well at the end of the day. It was a bit of a challenge for us.
And some of your milestone projects, I think you mentioned one in Parktown.
Yes, we've got the project we've just completed in Parktown for a private landowner who is busy building a new house on a very steep slope, so he needed to retain part of the slope where he was building his swimming pool. So we assisted with the design of the structure for his engineer, and we assisted with the team of specialised gabion installers. That project was finished about 2 weeks ago, and looking really good, so we'll be able to show you some nice before and after photos for that job.
Excellent, Louis. Right, I think in closing, what is the future for environmental engineering and gabions in Africa, and perhaps where can we assist industry in terms of small medium enterprise development?
Well, I think there's huge scope for improvement. I think internationally they're quite a lot ahead of us, quite far ahead of us in terms of technology, but we can quickly adopt that technology here in South Africa to create a lot more opportunities for these small emerging contractors to quite easily pick up steam and give us the solutions we provide, and that's what we're really quite excited about. In South Africa, we're quite far ahead when we compare ourselves to the rest of Africa. Countries like Angola, Zambia, Zimbabwe, they're way behind. So South Africa, the past 10 to 20 years, there's been certain backlogs that need to be fixed. But in Africa, there's huge opportunity for job creation and environmental engineering to take it forward quite radically. So the research that's been done internationally could quite easily be and quickly implemented to help us going forward, and that's where we see ourselves in the future. Those opportunities are quite exciting for us.
Great, Louis, thank you so much for your insights on environmental engineering and gabions. This has been Alistair Curry for CPD On Demand.